Hello everyone, this is Mr. Millen, and I'm here with the first part of the companion notes on changes in scale on perimeter area, surface area, and volume. So the first thing we're going to talk about here is the two-dimensional figures. And when we change the scale of something, so we might change the length or the width or the base length or whatever else, the changes in scale affect the perimeter and the area. Okay. Now, that depends on how many dimensions you're changing, but also as well as how they are multiplied. So they might be doubled, tripled, quadrupled, quintupled, anything like that. So let's look at number one. It says, look at the square below. If the side lengths are tripled, what will be the ratio of the new perimeter to the old perimeter? So how do we find the perimeter of a shape? Well, the perimeter of the shape is all of the sides added together. So if this is a square and we have a side length here of 8 and a side length here of 8, then both of these will have to be 8 centimeters as well. So our perimeter for our old perimeter would be 8 plus 8 plus 8 plus 8, which is 32. So 32 centimeters is our perimeter. Now, it says the side lengths are tripled. So that means that we're going to multiply all of these sides by 3. So our new side lengths are going to be 24 all the way around. And so our new perimeter is going to be 24 plus 24 plus 24 plus 24, which is 96 centimeters. And it wants to know the ratio of the new perimeter to the old perimeter. So the ratio of the new perimeter to the old perimeter would be 96. Well, you do new over old. Your new perimeter is 96. Your old perimeter is 32. And if you divide those, you get 3 over 1. So your new to old ratio is going to be equal to 3 to 1. Now, the perimeter ratio, when you do those, the perimeter ratio is going to be the exact same as your side ratio if all of them were tripled or doubled or whatever else. So our original side ratio would be 24 over 8, which would be 3, which is the exact same thing that our perimeter ratio is. So the ratio of the sides will always be the same as the ratio of the perimeter if all the sides have that same ratio. Now let's look at number 2. Number 2 says, look at the rectangle below. If the side lengths are doubled, what will be the ratio of the new area to the old area? So how do we determine the area of a rectangle? Well, according to the formula sheet, the area is equal to the length times the width. Well, in this case, our length is 4, or you could say 10, and your width is 10. 4 times 10 gives you 40 inches squared. Now it says the side lengths are doubled, so that means we're going to double both of these. So doubling 10 gives us 20. Doubling 4 gives us 8. So our new area is going to be length times width with the new length and width, so 20 times 8. And if you do that, you get 160 inches squared. So the ratio of the new area to the old area would be 160 over 40. And if you do 160 over 40, you get 4 over 1. So our ratio of new to old is 4 to 1. Now there is another way you can do this, and it's based on the formulas. Now, we said that the side lengths were all doubled. So what we did here is we doubled the length, so that became 2L, and we doubled the width, which became 2W. So if we do 2L times 2W, you get 4W, or 4LW, excuse me. So if you compare the old, which is just LW, and your new, which is 4LW, and cancel out what is common, the L and the W, That leaves you 4 as your new one and 1 as your old one, which is the same ratio we got here. And we're going to use that method to determine the ratio in number 3. So in number 3, it says, look at the rectangle below. If the side lengths are tripled, what will be the ratio of the new area to the old area? So side lengths are tripled. What would be the ratio of the new area to the old area? So our old area is given to us by length times width, and our new area is going to be given to us by, we're tripling the side length. So we're tripling the length and we're tripling the width. So 3L times 3W, 3 times 3 is 9, and then the LW comes out. So what is the ratio of the new area to the old area? Well, if you take 9LW divided by LW, the LW's cancel, and you get 9 over 1. So your areas have a ratio of 9 to 1. The other way you could do this is by calculating it. You can also use the ratio of the sides. Now, we talked about this when we talked about similar figures. The side lengths are all tripled, so that means they all get increased by a factor of 3. Well, if we're looking at the ratio of the area, area is measured in squared units. So that means to get from our side ratio to our area ratio, we need to square these. And of course, when you square 3 and 1, 3 squared gives you 9, 1 squared gives you 1, and so you end up getting the exact same thing. And again, if you did it by the length and width and found what the actual areas were, you would find 9 to 1 as well. All right, so let's look at number 4. Number 4 says 2 similar triangles have a side ratio of 3 to 7. Answer the following questions. The first one asks, what is the ratio of the areas? So we have a side ratio of 3 to 7, and they're similar. So that means to get to our areas, we need to square our side ratio. So if we do that, we get 3 squared to 7 squared. 3 squared is 9. 7 squared is 49. And that would be our ratio of the areas. Next up, if the area of the larger triangle is 9,800 square feet, what is the area of the smaller triangle? Okay, so our ratio of the areas, we're looking for an area here, so we're going to need to use that ratio. So we're going to write it as a fraction, 9 over 49. 9 is your small triangle, and 49 is your large one. So your 9, do we know what the area of the smaller triangle is? No, we don't, because it says the area of the smaller triangle here. So X. Do we know what the area of the larger one is? Yes, we do. It's 9,800. So we're going to cross multiply to solve this proportion, and we get 49x equals 88,200. Divide both sides by 49, and we get x is equal to 1,800 feet squared. So that would be the area of our smaller triangle. All right, let's look at number 5. Number 5 says a rectangle has a length of 7 feet and a width of 12 feet. If the width is quadrupled, what is the ratio of the new area to the old area? So all it says is the width is quadrupled. So we're multiplying the width by 4. Okay, but we're not doing anything to the length, so we can't use the ratio of sides for this. However, we can use our formulas. So the area of a rectangle is given to us by the length times the width. And our new area, we're not doing anything to the length, but we are doing something to the width. The width is quadrupled, so that becomes 4W. 4W times L gives you 4LW. So what would be the ratio of the new area to the old area? Well, you would have 4LW over LW. The LW's cancel, and that gives you 4/1. So your ratio of the new area to the old area would be 4:1. Okay. And we are going to skip number 6. It'll be on a key or something with this, but you know, you guys don't need to know that for the IXLs that you'll be doing. So that's going to do it for the first part of this video. I will record the second part soon and put that up. That one will be on 3-dimensional figures. However, it goes pretty similar to the 2-dimensional figures. Instead of the area, you would be doing the surface area and volume. Okay, so I will be back with that part of the video. Thanks, guys, and I will see you in the next one.